Okay. I'm going to present you a paper about analyzing disk arrays. Okay. So, first of all, what's a short introduction? Okay. So, what's a disk array? Disk array is a storage management computer. Okay, and it composed of disks, which their structure is an array. Okay, it has like a data structure, which is array, like the one there. Okay, and who uses it? All companies, institutions, governments, everyone who needs to save their data in a storage needs that. And the biggest storage manager is Amazon Web Services, not Google, not IBM, Amazon. Okay. In this paper, they try to analyze disk array, which is HP, okay, HP FC60. This disk array system has two controllers, and controller A and controller B, and those controllers manage to take data and send data to the disks, and they configure their disk array in RAID, and which is the acronym of redundant array of independent disks. Okay, so, and they configure as RAID 1, 0, which means that when you write the data to the disk, it has a copy, another copy. It is called mirror. Okay, so you have basically two copies of each datum. So, and the good part is if you lose one of the copy, okay, one of the pairs, the other one will serve you. And we have array cache, which is like the CPU. You can think like a CPU, but as a basic computer, you have a cache and memory and disks. Okay, but here we have array cache and disks. There is no memory. Okay, if I not see. So why do we need to analyze them? Because first of all, those components are like closed source computers. Okay, they don't have any. The manufacturers don't provide the algorithms explicitly, even though they publish a patent. It's hard to maintain the source code. So since it's source data, and as we know from the computer architecture, the disks are the slowest components. So we need to try to make optimizations or try to manage them to serve as the maximum throughput. And disks are the bottlenecks, so we need to analyze them for better response times and throughputs. And I want to say explicitly the drawback of these systems, disks arrays, is they are black box. So you might not have access to optimization code or other. Okay, so you need to find a trick to overcome the issue in order to use it beneficially. So how to analyze? We can build simulation models, which is costly and takes time. And the other one is analytical models, which is dirty but cheap and quick. So in this paper, they tried to build a model by using the analytical model. Okay. The baseline model is actually for analyzing the overall structure. They need to build a model, but first they need to build a basic model, baseline model. So they need to specify the key components and specify the workload, because this computer system will continuously take streams. So there is a workload for that. They need to specify the workload too. And they are going to combine those two, and also they will in later slides, we will see that they will also explicitly set some parameters on disks, so the baseline of the model will be built. So key components are, so as I said earlier, there are two steps. Okay, first we will go into, actually they did specify the key components, and they will they specify the workload of the system. But first, the key components. The key components are, since we have array cache, and the data comes from, I'm not sure if it's written, but the data comes from here, so it will take the check the array cache first, like the CPU. If it doesn't, it will go to other sources. So the first component is array cache, and the other component, the second component, the second and only component is the disk. Okay, so two components. These are the keys. Yes, and this is the specification of the hardware model, the HP FC60. So they say it's written that the cache size of the each controller and other things like that. So, and also they need to characterize the workload, and this workload is going to be like read and write model, because you can only do two things for the disks, read or write. And we need a workload which are composed of this parameter, which will contain those parameters. Okay, and so we will have an input stream, and the CPU today we need to count the request size, type, and run count, random count. So read and write operations. So read model is a queuing server, okay, and the system works like this for the read operation. So from CPU terminals, it will check the cache. If it's not in the cache, it will go to the disks. Okay. For this, it will add parallel queuing server. It will check the disks parallelly. So it is a parallel queuing server. But if it's not, if it's in the cache, so it will go back. So it will take the data immediately. So it's a single queuing server. And the write operation, or the write model, is a state diagram, but it uses write-back caching model. Write-back cache model is a cache. Okay, it's a limited size. It has a buffer, it has a threshold. Okay, if it exceeds that threshold, it will write all the data to the disks. So write-back cache means that it will wait until it loads, okay, until it exceeds that threshold, and after that it immediately goes to the disks for writing. So the baseline model is composed of key components, workload, and parameters of read-write operations. Okay, but there is a problem, and that problem is, since it's manufactured by companies and they don't they don't actually have to, but it's needed. Since they don't specify the optimization specifications, it creates a problem, because the parameters like this service time, overhead, and this access probability, those are available if we use the system specifications, but the optimizations are black boxed. Okay, so it's not even possible to play with them. So for the baseline model, for the baseline disk modeling, it's not. It will discard the optimizations. Okay, it will only consider the system specifications and workload specifications. So for that, by the way, but we need to also consider the optimization specifications, because at the end we need to know that okay, it does some optimizations. So also in the real model, if some system administrator wants to manipulate the system, it needs to find a way to use those optimization specifications. So for that reason, it will, first of all, it will create the baseline. Disk modeling, it is different from the baseline model. Disk array model, based on this array model, and it will compare the real, this disk array model with the real disk array. At the end, it will it will obtain the difference. So it will be obvious that the system used some kind of optimizations. And there are three types of control optimizations: access coalescing, redundancy-based load balancing, and adaptive prefetching. First, the papers specified the disk array modeling. Okay, it gathered the data. Okay, now it's going to compare this with the real system. So, access coalescing means that if we have a data which is continuous, since it's an optimization, we don't have to write each data to separate disks or separate levels of disk. So access coalescing means if something read or write happens, continuous read or write happens on the same data, it will, the optimizer will put that data on the same disk. And redundancy-based load balancing means the architecture of the system is RAID, which is redundancy-based. And since it goes to both levels, there is a copy and there is also another mirror. Okay, but when the input comes, it will try to balance those things. But it can balance under two circumstances. I consider them. Or it's going to reduce the disk transfer time, or it's going to reduce the disk queue length. And adaptive prefetching is another optimization technique, which again considers the continuous stream, continuous data. And the system by itself thinks that, okay, this is a continuous stream, so I'm going to take that data from the disk automatically to the cache. So there will be, the processing will be much faster. Oops. So they compared data. I didn't put any graphs because at the end they conclude some. They validate their results, but something interesting happened for that specific HP FC60. They say that okay, first of all, reads. There are two operations, reads and writes. But reads are better than the writes. However, the performance under small random reads are equivalent to the write operations, small write operations when the cache is full. And this is, they say that this is awkward because this implies that because the write back cache policy ensures that it is better than write direct. So this is. For that reason, this is awkward. It implies that the write-back cache algorithm needs improvements. That's it. Any questions? Soru mu istiyorsunuz? Ya soru şu olabilir. Şimdi bir defa yaptıkları model çalıştığı biliniyor. Valide etmişler. Ya burada yani
Bir kere güzel bir makale bu. Şöyle güzel. Elinizde donanım var. Yayın çıkarmanın kolay yollarından ben çok fazla yayın yapan bir hoca türünde değilim ama kolay yollarından biri bu şekilde karşılaştırmalı bir analizle performansları çıkartıp şu çıktı bu çıktı deyip çalışmanızı bitirmek. Yüksek lisansta birinci hedefiniz tezinizi bitirmek olsun. Güzel bir şey yaratmak olmasın. Yani dünyayı kurtarma peşine düştüğünüz zaman teziniz bitmeyebilir. O yüzden bu ona güzel bir örnek teşkil ediyor. Sınırları düzgün çizilmiş bir çalışma. O örnek olarak koyduk. Zaten konu da biraz iyi bir konu. O açıdan önemli bir makale. Yani basit gibi gelmesin size.
Yok değil zaten.
Aha. Buyurun.
Yok yani soru şey olabilir. Yani niçin böyle bir tekniğe, neden böyle bir tekniğe ihtiyaç var? Yani cevabı da şey aslında. Çünkü yani işte
nasıl bir tekniğe? Onu da şey yaparsınız.
Neden böyle bu şekilde analiz etmemize gerek var? Böyle bir disk array'i neden analiz edelim? Birincisi sistem kapalı sistem olduğu için bütün algoritmalar verilmiyor. Yani optimizasyon, özellikle optimizasyon algoritmaları verilmiyor. Evet, bazı işlemler kesin. İşte hani diskten bu kadar sürede okuyacak, işte şunu şu kadar yapacak, keşif bu kadar. Bunların hepsi hesaplanabiliyor ama algoritmalar şirkete özel olduğundan ötürü kesin bir şey, yani bir şekilde bir yaklaşım yapmak gerekiyor. Bu da hani hızlı ama biraz daha kirli bir çözüm. O yüzden dolayı yani sistem işte administrator seviyesinde, admin olarak görev yapan kişilerin bu şekilde sistemlerini optimize etmeleri sağlanabiliyor.